next challenge is entitled Wraparound. Create a function to reproduce the wraparound effect shown. Let's look at the examples to see what they mean. Consider the text "Hello World," that common phrase that we see in programming studies. And they give us an offset of 2. So we know these are zero-based indexing. We'll hit the letter L, this first L then, with the offset of 2, 0, 1, 2. And you can see now, imagine the string starts at this point. You get the LLO, world, exclamation mark, and then the part that was cut off is just tacked on to the end, like so. And then we should probably mention the notes. The offset can be negative, and it can be greater than the input. So they threw a wrench at us there a little bit that we have to handle. Then consider an offset of -4, right? You'd count, if this is 0 position, count 4 backwards. That comes to 1, 2, 3, 4. And you can see the sentence starting here, right? And then they tack on from the beginning, what I gav. And that's how you get that. And so for the length 30, you got to basically use the length of the string to determine the index from it. There's an operator that we've used a number of times that hopefully pops into your head for that, but that's what you'll do there. And then you have a little bit of both here where you have negative and an extremely high offset, much greater than the length of the string that you have to worry about. But we have all the tools for this, so let's get to it. Head over to code. You know the drill. Now you pause. Now you give it an honest effort, and then come back whenever you're ready. I'm going to set up some local variables here that'll help me think about this problem and help make it more readable too. First things first, I know I'm going to be dealing with the length of this input string a lot, so let's just make a variable for it to refer to. And then we know the strings have this property called length that determines that. We have this issue of negative numbers we should worry about. Let's call it is, what offset is negative. This isn't entirely necessary, but it's a little more readable. You'd probably just refer to offset is less than 0 if you'd like. For this part, you could do that. And then finally, we have the issue of the offset being a much larger value than makes sense for the length of the string, where you sort of think of the concept of a circle, right? You can technically go beyond 360 degrees. You can have 720, for example, and it puts you right back at the same spot. So it's kind of like that thing. We need to deal with that. I'm going to convert this into a meaningful index that's within the range of the input size. I'm going to call it, let's call it normalized offset. And for this, hopefully you thought of the modulo operator. So if we take the offset modulo the length, that should get rid of all the, that should give us just the remainder of if we divided the offset by the length. And that's what we want for our index. Hopefully that's clear. We've kind of used this concept for indexing into arrays and that sort of thing. But we can review that if that's not clear. Probably is now in the hard series, so I'll leave it at that for now. Then we have the idea, so it could be negative, it could be positive. I'm interested in the magnitude regardless of the offset, and I can get that with an absolute value, which we've seen before. The system class should cover us there. So if we take the absolute value of the normalized offset, that'll give us the magnitude, how big the offset really is in a size that's appropriate to the input. Okay. Then I'm gonna build a couple strings, I think. I'm going to take it first from the proper left to right order, and then whatever part got cut off, I'm going to sort of tack on at the end. I'm going to make two separate strings for this purpose. Call them maybe original and string. Let's call it cutoff. And then at the end, I'll just do something like return original plus cut off. Okay, but we're not quite out of the woods yet, right? So I'm going to want to sort of handle both cases of where the input is positive or negative. I'm going to make a general start index that I'm going to use to index into the input string to get the two different strings that I want. So let's go with, if it's negative, we'll consider that case first. I'm going to use the ternary operator here. Then I'm sort of want to take it from the counting from the back side. If it's positive, then I want to count from index 0 going to the right. You know what I mean? If it says to take a negative offset, then that means I should have been going starting at the end, counting to the left. So hopefully that's clear. If the offset is negative, then what we want to do is take the length, which would be the end of the input string, and we'll subtract the magnitude that's going back from the end. And then otherwise, we want to go from the start and move right. And in that case, we can simply say magnitude. That's how far over to go to the right. And so this start index now is relevant for either case. So that's pretty handy. The original then becomes, we know that strings have a substring method, and if you pass just one parameter to it, it basically says start at this index in the string and then just take everything after it. And that's pretty handy, right? That's sort of what the problem does. It takes everything else to the end, and then whatever letters before the start index sort of get wrapped around. So this should be good right here. And then our cutoff portion, we'll use the substring method again, but we'll use the two parameter variety, where this time we're starting from 0, right? The cutoff portion is going to come from the front, and it's going to go all the way up to whatever that start index was. And if you recall, though, the second parameter, unfortunately the name doesn't play so well here. It's actually the number of letters you want to take. So while this looks a little bit strange that it might grab an extra letter, a duplicate letter here, it will not. So remember that the indexes are 0-based. So consider an index of 2, right? You would have 2 as the start index, and that would mean index 0 and index 1 both get removed. And if you count those, you see 0 and 1, that's 2 elements. So hopefully you see how that works out. We're taking 2 characters here. It's not that we're going from 0 to index 2 inclusive. It's just saying how many characters we're taking. So start at the beginning, take 2 characters in that example that I gave. Works out the same regardless of where the start index is. Same concept. So I think this covers us. I'll run it to be sure. Again, you didn't have to write out all these separate variables like I did. For me, they help me express myself more clearly than if you have a lot of mathematical operations. Just imagine for every one of these variables, had I used what's on the right side of the equal sign here. You know, it's fine. As the problems get more complex, it gets a little much to keep track of, but I like to do it this way. It reads well to me. and hopefully others. But anyway, let's make sure this thing even works properly first. Alright, cool. We passed. And if you wanted to see the tests, you could. They no doubt would have given us some ugly, yeah, negative 116. They gave us some really bad stuff. But we made a generalized case here that covered both negative and positive numbers. We accounted for a length being absurd, you know, a 5-letter word that had an index, an offset of 30 or something ridiculous. We accounted for that with the modulo operator, very handy. And yeah, figured out our start index, and I decided to do it like 2 strings here, but you certainly could have done something different. I would be very interested to see what solutions you came up with. Again, if any of this stuff is unclear, you know, I don't know where each viewer is at in terms of understanding and experience, so it's helpful to me if you just give me that feedback, what I need to explain more of, or less even. So, yeah, hit me up in the comments if you like, and otherwise I'll see you in the next video. Thanks.